Welcome to a Mad Scientist production of Surface Tension, in which we will look at how intermolecular forces affect the surface of a liquid. So what is going on at the surface of a liquid? Let's take a look by shrinking to the nanoscale. So here we are looking at the individual molecules in a liquid, and let's say that each blue circle represents a molecule of water. Due to kinetic energy, the particles that make up a liquid are in constant random motion, and so they will have a random arrangement. You might expect the particles at the surface at the micro level to form a random surface as shown here. But what we should find out is how do intermolecular attractions influence the surface? First, let's look at intermolecular forces under the surface, where attractions of individual molecules pull on each other in all directions. At the surface, pull on the molecules is lateral and downward. There is negligible attractions above the molecules, and so the net force on surface molecules is downward. The result of this downward force is that surface particles are pulled down until counterbalanced by the compression resistance of the liquid. Surface molecules are compressed more tightly together at the surface, forming a sort of skin on the surface, with less distance between them compared to the molecules below them. Surface molecules also form a much smoother surface than one would expect from randomly moving molecules. What do you think surface tension would do to a liquid not confined in a container? In this model of a small water droplet, what is the net direction of the force on the surface molecules? That's right, it is toward the center. And so a free-falling drop of liquid takes on a spherical shape. Here we see water dripping from a faucet. If this does not look familiar to you, turn on your faucet at home with very little pressure and see what happens. Or do an internet search for the behavior of water in zero gravity to get a great view of surface tension. Water in particular has a very high surface tension. Do you know the reason for this? What creates the attraction between water molecules? In looking at an individual water molecule, we can see the particularly strong attraction between the oxygen and hydrogen due to their opposite charges. Hydrogen has a strong partial positive charge and oxygen a strong partial negative charge. This strong attraction occurs between any water molecules close by. The strong partial charges result in a strong attraction between water molecules called hydrogen bonding. Interestingly, there are creatures that have evolved to take advantage of water's high surface tension. The water strider is a common insect that you may have encountered. What adaptation in their feet has occurred to take advantage of water's surface tension? Think about it. See ya.